Assalamualaikum warahmatullahi wabarakatuh. My name is Azri and I will be presenting about my final year project, which is formulation of chloride honey nanoemulsion using high pressure homogenizer. In 2017, the total farming area of stainless steel was reported about around 1600 hectare, and the number is expected to be increased yearly. This is next. There is two type of nanoemulsion, which is oil in water and water in oil. As my project, I will be using oil in water nanoemulsion. So as for my problem statements, the lack of KH usage in nanoemulsion technology, and next is the increasing demand of commercial products to use healthy and economically safe ingredients. So as of my primary objective is for me to investigate the formation of chloride honey nanoemulsion using high pressure homogenizer, and my specific objectives I have two. And first is to identify the optimum KH chloride honey nanoemulsion formulation using response surface methodology. And next, my specific objective is to investigate the chloride honey nanoemulsion morphology using transmission electron microscopy. So as you can see, this is the formulation of my, in this table, this is the formulation of my nanoemulsion. I have three different formulation. First is A1, A2, and A3. So the difference is at this row, at this column, where is oleic acid is the difference. The percentage of oleic acid is different. So as of A1, the oleic acid percentage is 1%, A2 is 3%, and A3 will be 5%. So and as you can see, glycerol and twin AT, this is the surfactant, and the co-surfactant, which is the substance used to stabilize the nanoemulsions. So below, I have listed the the procedure I have been doing to for my final year project. So first, I need to prepare the pre-emulsions. After I have prepared the pre-emulsion, I will be producing the nanoemulsion, which is I will be subjected to HPH, which is high pressure homogenizer, for 5 cycles at 100 megapascals. Then I will be observing the nanoemulsion for which is stability observation at three different temperature, which is 4 degree room temperature, around 27 to 28 degrees Celsius, and 40 degrees Celsius. After I have run the stability observation, I will be optimizing it using RSM, which is the statistical analysis also. Then I will be doing the FTIR analysis and TEM analysis. So as of my result and discussion, there will be 4 different parts, which is physical observation, stability and optimization, FTIR analysis, and TEM analysis. As of the physical observation, as you can see, I have divided it into three different row and columns. As you can see, the first row is for the day 0, and the second row is for the day 7, and as of the row 3, it will be day 14. And as for the first column, it will be room temperature. As for this second column will be 4 degrees Celsius, and as for the third column will be 40 degrees Celsius. So based on this physical observation, from the day 0, the physical appearance of formulation A2 and A3 of nanoemulsion, my chloride honey nanoemulsion, it appears that it appears to be milky. And as of for A1, all of it appears to be translucent. And later, after I have observed it until day 14, and for the A1 formulation, it had turned milky for room temperature and 40 degrees Celsius. However, at 4 degrees Celsius, it appears that it maintained the appearance as of its translucence between all of my formulation, and it is best to be kept at 4 degrees Celsius for 14 days. Next is the stability optimization of fluid honey non-immersion. So this is just the how I organize my RSM, how I use it to key in my to get my statistical analysis. So I have three different levels: -1, 0, and 1. This is just the symbol. So I will be using three factors: temperature, oleic acid, and storage time. So I will be studying the interaction between these three factors. So the desired target of my RSM is I am going to find out the size of the particle and the polydispersity index of the nanoemulsion. So the targeted value for the size is 0 to 100 nanometer, while the PDI value is 0.08 to 0.7. So this is just I'm showing the arrangement of my data to put in the RSM. This is the response surface plot. I have this is just the illustration of the interaction between all the factors. So I have made the plot for the particle size and polydispersity index. So for this response surface plot, I have concluded that the temperature will not affect the PDI and the particle size value. However, the percentage of oleic acid and the time of storage will affect the particle size and PDI value. Next, the experimental validation. This is what I get from the RSM. So after I have get this formulation, this formula, I'll make it the experimental validation. I'll get it. The percentage error is less than 10%, which is very good. So after this, for this experimental validation, it confirms that the formulation of A1 is the best between the three formulation, which is for 1% of oleic acid, and be kept at 4 degrees Celsius for 14 days. So this is the FTIR analysis. So basically FTIR analysis is to study the functional group of my nanoemulsion and compare to the original of fluid honey. So as you can observe, the functional group is all the same, but at the the wave number 1700, it appears to have a peak for all my nanoemulsion. So this peak is just to indicate the presence of just to indicate the presence of oleic acid. Okay, next, the TEM analysis. As you can see in figure A, shows the particle size of KH, which is less than 100 nanometer, and figure B shows the particle size of formulation A1 with 1% of oleic acid is the best, which is the best formulation, was also less than 100 nanometer. KH sample shows a spherical shaped particles similar to Prakash et al. 2018 and Lu et al. For linalo and citral nanoemulsions. However, for the formulation that I get, which is A1, some of the particles shows that it is an irregular shape. This may be due to the presence of oleic acid, which have different viscosity than fluid honey. So, there's a similar research, which is Abdu et al. 2018. His result and their result is the droplets of their curcumin sunflower oil nanoemulsions also have a non-spherical shape and size. As of the conclusion, optimization of fluid honey nanoemulsion made using RSM shows formulation A1 was the best. Furthermore, the optimization of fluid honey nanoemulsion was excellent, which is with 90% of confidence. On the other hand, results of TEM shows that the particle size of formulation A1 was less than 100 nanometer, which is confirmed, which is very good. However, the shapes of the particles were irregular in the TEM images. Hence, fluid honey nanoemulsion have the potential to be used in many industries such as pharmaceutical, food, cosmetics, and etc. As it is formulated with a safe and natural ingredient. That's all from me. Thank you.